Let me just check.
Yes, yes, I.
Yeah, it has started. Okay. So, ma'am, I will be sharing this video recording link with you.
Yeah, yeah.
So, dear participants, for today's session, if you could see, I have already shared one link with you. It's over here, where all those codes are being accessible. So, I'm copy pasting this link once again so that you all have access to this. Okay. So, just to tell you, if you click on this link, if it's in the chat box, it should open up MATLAB Drive for you. And you will see the codes, which is something like this. You can just right click over here and you can click on open in MATLAB online and sort of thing. So I would be trying to use MATLAB online and the offline MATLAB, which I have installed. Let me see if there are many students still waiting in the lobby. Okay. So before I start, actually, let me just try to bring this to your notice. We already have a MATLAB portal for you. So there's a MATLAB portal for your institute, Sardar Patel Institute of Technology. So all those institutes which are campus-wide license account, we have created a portal from them through MathBooks. And you'll find out if you want to access MATLAB, it could be accessed through this particular portal, or you can directly try and use any other browser where you feel like you can log in. So if you see all the things are present over here, sign in to get started. Then there are some resources for educators, some student programs, and all those sort of things. So if you have not created your account, you can click on, okay, let me share this link also with you. Yeah. So this is the MATLAB portal link for you. Oh, okay. So those who have not created their MATLAB account, they can use this particular link. If you click on this link, it will take you to your institute portal. You have to go to your portal and you need to click on sign in to get started. And then you can enter your email ID if you have already created an account. And if not, you just need to click on create one. You need to fill up all those details and click on create. You will receive one notification email. Okay. And then you would be able to access this particular account. So before I get started with this particular hands-on session, we'd just like to understand how many of you are using MATLAB online right now? You can use chat box, not an issue for that. So this will give me an understanding that you have an access to
Sir,
MATLAB right now.
probably these students are from CSE. So
Okay.
especially they are using for machine learning, they are using Python and all that.
Mhm.
Most probably the EXTC students are using MATLAB for the DSP and all that.
Okay. Okay. Fine. Okay. Yeah. So thank you, ma'am, for letting me know. Uh, So dear students, if you're using Python, this would be something really interesting for you to help you understand how MATLAB can be used as a powerful tool to understand, analyze, and uh, train machine learning models. Okay. So let me start with the presentation. If you have not access to, let us suppose, MATLAB, so it's fine. Let me just tell you that I have MATLAB 2023 installed over here with me. As well as at the same time, what I will be doing is I can go to my MATLAB online. And if you could see, I already have access. So if I type MATLAB online over here, so let me sign in. So I need to click on signing to your. What I could do is I could enter my email ID over here. I could enter my password, and then I would be able to use this MATLAB in my web browser. So for this today's session, I'll be using my offline version of MATLAB. Okay. So as discussed, set up let's set up this workshop by understanding a few terminologies, and then we'll move for the hands-on part. During this session, if you have any doubts, I will request you to put your queries in chat box wherein I can answer them, or you can unmute yourself and you can just ask your question. Okay. So I have already shown you your portal. I was thinking there is MATLAB online. Let me check, like I have this desktop version installation also. Let me check which one we can use with. I've already told you how you can use MATLAB login. You can create your MATLAB login. And I have already shared a link with you which contains the demo files. Right. Now, since we are not, most of you have not created this account, we'll skip this particular part. But let me tell you what basically this is. So when you try to log in into your MATLAB account, okay, you can have access to MATLAB Drive, where all the code files are available into MATLAB Drive. And if you click on the link which I have shared with you, you will get access to MATLAB Drive. And if you look at the preview, this particular folder is shared with you. So what you need to do is you need to just click on add to my files, and you need to click on copy folder. Once you do this, you would be able to have access to all these files, and you would be able to use them into your browser itself. So that there is no need to go for the actual desktop installation. So I've shared this link with you. If you want to try, you can try with this particular thing. Okay. Let's try to move ahead. Okay. Let me try to start this session with a fundamental question. So what is machine learning all about? So if you look at the scenario, and if you look at, a thing like what a concerned person asks a question to a kid, like if all your friends are jumping off a bridge, would you like to follow them? And we'll find out that a kid answers yes. That is how machine learning algorithm will try to work, because it will try to follow the trend. Now, if you think logically as a human being, this is not correct. But if you look on the left hand side, you have a figure over there, you have a data, and data is very messy, right? So if you want your algorithm to be intelligent and give you correct logical reasonings, we need to grab the data, we need to remove what you can say ambiguities with the data, and only then we can go for the training part and all that. So this was just part of thing to get started, okay? And you can find out that why the answers are wrong. So I will talk about this when we will move ahead with some hands-on kind of sessions. Okay. Okay. So let's talk about where machine learning is being used. So we find out machine learning is used in each and every application. Just to give you a glimpse of it, if you talk about the first case study, which is from Bristol, wherein we are trying to understand the life cycle of a tire, because the nature of the roads would be different, right? There may be some city roads which have potholes. There may be highways where the roads are very good. So according to the nature of road, we are trying to find out what could be the wear and tear and what could be the actual life of a tire. And then we find out that people will tell you that after certain kilometers, the tire should be changed, right? If you talk about other kind of things, let me show you something with respect to this BMW kind of case study. Okay, wherein MATLAB was being over here and a machine learning model was developed to detect the oversteering. So we know that if there is an oversteering, In that particular case, the vehicle tires lose their grip, the friction is lost. In that case, if it's a slippery condition and the steering is rotated too fast, we can find out that the accident could occur, right? So if we find out how this particular thing was handled out, we can understood that at BMW they have used a machine learning approach. They use MATLAB over here, and the model which they were interested in a supervised machine learning model, right? And then when the model was developed, the working prototype, okay, was flashed into the ECU. So ECU over here is an automotive microcontroller, okay, which was able to detect the oversteering. And if you talk about the accuracy is 98% accuracy over here. And since we are going to do a hands-on session, what basically you'll find out what they try to do is, uh, they try to capture the data, right? So you can see they try to capture about certain data points. The vehicle was being drawn off on a road. You can look at the terrain of the road, right? It's more circular. Okay. Then it was being visualized. So you can see the original one and the filter one. So it may be possible, that certain times there is no data available. And therefore, MATLAB was being used over here to find out those missing points. And then we can find out the original data and the filter data over here, right? Okay. And what was the next thing? The next thing was to find out the peaks in the sensors. So the peak will always try to indicate the maximum amplitude of the sensor, right? And that could be the point where we find out that the oversteering is very critical. So in MATLAB, we have these functions wherein we would be able to find out the peaks from the given signals, right? Next, now see, as ma'am has already told you, and like when I interacted with her, she has already covered some theoretical part where few machine learning algorithms have already been used, right? So what these people did was they have used our classification learner app, okay, and they tried different algorithms over here. KNN is very popular. KNN is then you support vector machines, okay. You have this discriminant analysis kind of things. But if you look over here, there were more data points, right? Some 3 lakhs data points were there, around 3 million data points. So they land into a problem of higher dimensionality, and therefore they have also used a concept of principal component analysis over here, and through which they find out they were able to solve the problem of overfitting. I will talk about overfitting into detail as we will try to use this classification learner app. And if you look at the result, now this is the what you can say a comparative analysis of different algorithms that were being used over here. So we find out now how you evaluate what you can say a machine learning model. Any guesses, dear students? F1 score, recall, precision, AUC, ROC, right? These are few things other than accuracy. So if you could see, accuracy was 98%, as you can see. Now, what do you mean by this? TF. So TF stands for true negative or true false, true positive, false positive, false negative. I'll talk about this when we look at the confusion matrix over there, right? Okay. And then the later part was to generate the code. So what they use was they use the MATLAB coder, right? And later on we find out that that was being flashed into that. So if you look at the conclusion of this particular case study, what you'll find out, we find out that they have successfully developed a machine learning model for oversteering detection. And the main thing was they were able to deploy it on the microcontroller, or possibly we can say an automotive microcontroller over here, right? And what is the next point of action? Nowadays, it's possible to have memories. These memories can store a vast amount of data, okay? And single vehicle can give you a lot of data. So if there is more data, what we can find out, machine learning can provide an opportunity to develop some algorithm that can also be used to learn the driver's behavior and improve the driving experience. So most of the time, students and faculties will ask that how machine learning approach is being used for industrial case studies. So this is one of the best case studies you could see with respect to automotive domain. And I think the same could be replicated out over there for you. Okay, let's so let's go back to uh, the presentation deck. The same thing is over here now. Even that can be used for engine health, that is for predictive maintenance. Then you have forecastings and so on. I'll be sharing the slides with you so that later on you can go and you can give some more detailed information over here. Right. So after understanding what machine learning applications and industrial case studies are there, let's try to quickly understand what is machine learning. I know that part has been already covered, so I'm not going into detail. So what is machine learning? So machine learning is basically an ability to learn from data without being explicitly programmed. But then there are certain challenges. If you look at certain applications with respect to speech processing, there is speech recognition over here, object recognition, or health monitoring of an engine, we'll find out that here the number of parameters are more. And if the number of parameters are more, and if I try to go for an analytical solution, that solution will be too complex for handwritten rules or equations. So the task over here would be to learn complex non-linear relationships. Next, what if the data is changing with respect to time? Now let me tell you how what this could be. So during monsoon season, we may find out that it will be really difficult for you to go for weather forecasting. There may be hailstorm, there may be wind which is moving with a speed of 100 kilometers per hour and so on, right? Next, energy load forecasting. This is one of the major challenge because during the daytime, the amount of electricity consumption is more compared to during the night time. So probably during monsoon, if you have a hydropower plant and not able to generate that much electricity, this analysis will help you in understanding and forecasting the energy load. Similarly, you have stock market predictions. So that as the data is updated and more data is available, our machine learning model should be able to perform well when access to this data. Next, let's take an example of IoT analytics or taxi availability or airline flight delays. Now, these are very critical applications where we find out that if we talk about an airport, within a minute we'll find out some 30 number or 40 number of flights are operated, right? So our model can learn effectively from very large data sets. So these are some of the challenges and solutions we look for when we talk about different applications over here. Just to quickly understand the type of machine learning models. So a machine learning model can be differentiated into two parts, we can say. The first is supervised learning, wherein we say the data is labeled. And here we can develop a predictive model because this model can accept inputs, which is the labeled data, and will can generate output. So this particular task get divided into two parts, if you could say. Now, what are these two parts? Now, these two parts are, the first is the regression one, wherein we can find out over here, we are talking about the forecasting, and you can look at the two graphs. So what you see over here, this is load, this is megawatts, and this is the day-wise prediction. So on the historical data, the model has been trained and it is trying to predict you, what you can say is the load forecasting. So in regression type of algorithm, either it could be only a single number prediction or it could be continuous value prediction. So in our particular case, it is a what you can say continuous value prediction. And the second graph you can look over here, it's all about the error plot between the original one and the one which has been predicted by our model. The second task under supervised learning is classification. Okay. So can someone quickly tell me something about what could be a classification problem? Any idea? Let's take an example of a smartwatch that you're wearing. A smartwatch is able to calculate the number of steps as you're walking, and it can also perform a lot of things like heart rate detection and all those sort of things. So just to tell you that your mobile phone consists of main sensors, wherein it has some accelerometers and gyro, and we would be able to collect certain data through our mobile phone. And based upon that, we can find out, we would be able to classify, we would be able to classify based upon the data if a person is walking. So this is a class 1. If the person is climbing, class 2. The third class, if person is sitting over here. What if he is standing? And the last one is, what if the person is laid down on the bed? So what we will find out, we'll find out that based upon the data X, Y, and Z, I am able to actually learn from the data different patterns, and then I could classify the output. So here the problem is to identify the human activity. And let me tell you that you can use MATLAB in your mobile phones also, wherein we can replicate this kind of thing over there. Probably we can do this in a hands-on session. So I hope you are able to understand now how what is regression and what is classification kind of thing, right? Any challenge if you have, just let me know. I would be happy to answer that. Okay, let me see how many of them are still waiting. I hope there are no people waiting right now. Okay. So let's return back to our presentation. Under unsupervised learning, we find out that we do not have label data. So if you do not have a label data, basically what we'll find out, that, here the data is not labeled. That is, no output is available. You only have an input data over here. So what task would you like to perform with respect to this? So the task is basically of clustering. So if you look over here, we have been given an engine speed and the vehicle speed, and we need to identify the clusters. So how the clusters are classified? So the first one is represented by red color. Then we have, this is second cluster, we have third cluster, fourth one, and fifth one. Another way you'll find out, if you have a data, something like that, okay, and some random points are there. For example, these points are there. Okay, random points are there. And then this is X variable and Y variable. And then we would be interested in clustering and understand the clustering pattern. In that particular case, we'll find out how the cluster is it's forming. So we can find out that this is cluster 1. This one is cluster 2. And then we have a cluster 3 over here. Okay, so this is cluster 1, then you have cluster 2 and 3. So in this way also we'll find out that the clustering takes place. Fine? Okay. So as we are going to use MATLAB today, we will first try to understand how MATLAB provides an end-to-end solution to develop entire machine learning workflow. Let me divide this into certain number of steps for you so that it becomes easier for you to understand. So as we move from left to right, we will be talking about different process that we are taking over here. The first one is to understand how to access the data and explore the data. If the data is messy, what we are going to do with this data. So this is step 1. And step 2, we'll try to pre-process the data. Okay. Step 3, we will decide, okay, if there are more number of parameters over here, what we should do. Should we go for principal component analysis? should we go for identifying what are the different predictors that are more relevant with respect to the output, so that only those could be selected for training the model, and the one which are not relevant could be dropped. Next, and step 4, what you try to do is you try to go for different machine learning algorithms like KNN, ensemble, random forest, backtree, decision tree, and so on. And later on, you may try to go for model tuning in case you find out that your model is not giving you correct answers, or you feel like it should give you more classification accuracy. And in that case, you can find out you will go for model tuning, which is also known as hyperparameter tuning. Let me check if this particular step number 5 could be shown to you today. Uh, if the time permits, I will try to show you this particular part. So just to quickly revise the steps, because we will be going through this. So step number 1 is to access the data. Data may be into text file. It could be into an Excel spreadsheet. If the data is too large, in that case, you might be using some database management software. So it could be through databases and so on. So the first thing is to access the data. Next step, step number 2, is to find out if there are some missing values in the data, because this missing values will be represented by NaN, which is not a number. And in that particular case, we could not train a model. So I'll just try to show you if there is a missing data, how this missing data could be filled up. Well, we'll find over there. Also, if there are some outliers, I hope you understand outliers. Okay. So if there is an outlier, there is a data point which does not fit to our generic data, then what we should do with this outlier? Should we reject it? Should we include it? Okay. Step 3. So step 3 is about feature engineering. Now, let me tell you that what if you have an audio data and you want to classify certain commands like yes, no, and so on. Or there is one data set which will show you that MATLAB is a very good example for that. Pre-spoken digit data set, wherein the numbers 0 to 10 are being recorded in the form of audio. There are 30 odd recordings for each digit. And then we are trying to use some audio techniques to extract some audio features because the data is too large. So in that case, here we'll only go for the features which are more relevant. Okay. And hence the case we find out it's written over here domain specific technique. Right. Next step, once we have this data with us, we are quite confident that these are the only data sets that are relevant. We'll go for machine learning apps. So we have classification learner app, we have regression learner app. We'll be looking at that today. We'll train the model, we'll export the model, and then we'll go for testing of the model. And if everything seems to be fine, then you can go on generating a code and think to flash this particular model. So I hope this particular process is clear for you, so that what we can do is now we can go with actual hands-on sessions. Okay. Fine. So let's try to understand our first example. So our first example is all about predicting the fuel economy. What's our goal? Our goal is to predict the fuel economy of a vehicle. So what we are going to do is we are going to use an app over here, MATLAB app, where we are going to build the initial model without any coding, or hardly a coding, we could say. In this case, we do not need to be a regression expert. Let's focus on data set. So if you look about data set, there are predictors and response. So let me explain you what predictors and response are first. So I may have certain number of columns in my data set. Now the output column, which we want to predict, will be always a response column. And the columns on which the model is to be trained will be the predictors. So if you talk about this particular data set, we have vehicle horsepower, weight, cylinders, number of cylinders, the year in which this model was brought up as predictors. And at the output, we will find out we need to predict the MPG. So what are the different steps that we are going to follow? So the different steps that we are going to follow are, okay, the first step will be load the data. We'll try to find out if there are some missing numbers over here. We'll go with the splitting of the data so that we can divide it into train and test. We'll train the model. So different regression algorithms could be used. I will let you know what are the different metrics on the basis of which they are being evaluated. We'll go with the test model and then we can go with a new vehicle data, right? So before I go to this, just wanted to understand, do you have any challenges? If yes, let me know because now we'll be going with the hands-on part. Any challenge you have, dear participants? Feel free to ask the questions. Let me see if there is something in chat. Yeah, okay. Nice. So if you see, I have my MATLAB drive over here. And if I go to add to my files, I can click on copy folder. Okay. So now it's asking me to, let me just, so that's how I have used my own, what you can say, the password. So if I go to this shared container, I can find out I have my folder over here, which is MLDL 12th of April. Now for you, you'll find out only one folder over here. So how you access it? Once you go to MATLAB drive, you will be under files. You need to click on shared contained. Under shared contained, since you've copied the folder, you'll find out this MLDL 12th of April. I click on this. It will also show you the owner, like I'm the owner for this particular folder. What I could simply do is I could right click on it and I could click on open in MATLAB only. So now what we find out? We find out that we are launching MATLAB in an online mode through our browser. So since most of you are from what you can say from CSA background and have not used MATLAB before, so just to quickly give you a glimpse of what MATLAB is, how it is being organized. So I have a home plot, I have a plot tab over here, I have an apps tab. So this is home tab. I have plot tabs. I have app tabs over here. Okay. So what you can do is, the first thing that basically I will suggest users to do is you can go to home tab. You will find out an layout option over here. So you can click on two column. So right now it's default, it's two column. And then I can also go for three column. So basically, let me explain you this three column kind of thing. Okay. So I could see now that this horizontal part, this part, this part is known as MATLAB tool strip, wherein you can navigate to different tabs. The home tab gives you some features. In plot tab, you can go for data visualization. You have app tabs over here from where we will be accessing the regression app and the machine classification learner app. Next is you have this directory over here. So it's just telling you the location of the demo files. It gives you the location of the demo files. which are present in this location. I have a directory over here. So this is a directory which shows me the current folders which are being active. Now all this folder consists of codes and demos and data. So we can say basically here my data is present or the data set is present. Next window. So this is, I could say, window number 1. I have a data. Window 2 is a command window. So if you are able to see this 2 greater than sign, this is known as command prompt. And basically we enter few commands like, just to give you understanding, that if I enter 2 plus 3 over here, it is supposed to give me answer 5. So that's what we do. We write commands over here. And in return, we get some answers. So this is window number 2. Now in the third window, which is a workspace window over here, we will be able to see all the variables, temporary variables that have been created over here. So as we move ahead, we'll find out ML models, machine learning algorithms or ML models to be appearing in the workspace. And then our task would be to export that models so that they could be stored into our current directory, that is window 1, and later on it can be used for some other purpose. Okay. Right. So let me quickly enter a command over here just to explain you what I was talking about. So 2 plus 3, answer is 5. So that's how it works. And if I type this command who, it will give me a variable which is present in my workspace window. At present it is answer because I have not assigned any variable. So what MATLAB will do is it will try to take a global variable known as answer and will try to store the result into it. But what if I do this? Okay, I want a square of a number. So variable is SQ. And what if I write square of 2? Let's see what does it gives me. Okay. So basically it's taking a square root of it. Right? But what if I enter like this? SQ is equal to 2 to the power 2. Right? It gives me answer 4. And if I want to check the output of SQ, it will give me answer is 4. Now to clear this particular window, you can simply type CLC. So the command window is now clean. We can type this command who over here. And the who command basically tries to tell you the variables which are present in your workspace window. I think this is clear. So I want to clear the command window. So I will type CLC. Also, I want to clear a workspace window. So I will type clear, enter. And I would find out now I'm ready to use MATLAB for my own purpose. So let's click on this vehicle 1, vehicle folder. And if you see over here, I have a data set with me. Let's look at this data set. So basically, if you see, it is an Excel sheet, right? So let me double click on this vehicle data set. So can you quickly notice few things? Can someone let me know how many number of predictors are there over here? And how many number of columns are there? So if you talk about column A, it talks about the type of vehicle. So there is car, truck, and so on, right? And hence the reason you'll find out what is the data type of this column, categorical. Now, what you can do with MATLAB is you can change the data type of the column from categorical to what you're interested in. That is text, number, date and type, duration, and so on. So from here itself, we'll find out we can change the particular data type of the column. Next, we have engine display, that is engine speed. You have rated HP. Then you have transmission. Again, it is categorical as you can see. Then I have a weight, which is number. Okay. And so on. And if you look at the column K, which is written as MPG, what we'll find out that It basically consists of certain numbers. Now, how many rows are there? Because rows indicate the number of observations. The rows indicate the number of observations that you have taken over here. Now, most of you might be thinking that this transmission is not helping me a lot, and the city traffic is not helping me a lot. I don't want to have this data. What you can say over here. So what I could do is, so what you can do is you can press the control key, select the number of columns A, B, C. I don't need D. I won't select it. I'll select weight. I don't need city highway. I need CO2 and I need MPG. Now, what are you looking at over here? I am unchecking column D and column I. And if I click on import data or import selection, it will try to import, only column A, B, C, E, F, G, H, J, and K. So let me try and show you this. I've imported this, right? And if I try to go to MATLAB workspace, this could be accessed by vehicle data. Enter. I'll show you this. I'll close this for a moment. So it will show you how many number of rows are there. But if I want to check the size, can you see how many columns it shows you? It shows you there are 9 columns. But the actual data has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 columns. So this is one way by which you can directly select columns from here without actually writing a code. That is how powerful we'll find out MATLAB is. Anyways, like I need to check for missing values, right? So this is one way. So I have it over here. Now, how to import this data? So, okay, the first thing is look at the first row. You have the variable names, car, truck, engine, display. So you can decide over here number of variable rows 1 and 2. Right? So if I go over here, basically it highlights the number of variables. Next, by what name this particular data set should be loaded into MATLAB? That I could specify over here. So you can specify vehicle data, which is a name directly assumed by MATLAB. If you want to change it, you can change it. Most important thing, how you want to export this data. There are options to do this. So this app gives you a number of options. Can you see these options? Timetable, column vector, and so on. I'm interested into table. So I'll select this as table. Now in table, you have options. Now, what are the options? The options are allow all characters in the variable names. Now, what do you mean by this? To tell you, let's talk about this particular column where we have this EV speed ratio. Sometimes the variable length will be so large that MATLAB will try to truncate it. And in that particular sense, you'll find out that that particular variable become meaningless. So in that case, you can go to table, you can go to this table option, and then you can click on this limit variable names to be valid MATLAB identifiers, or you can click on this option, allow all the characters a variable name. I'll choose this one. What are the other options? Specify the row times and all that. So we are not going for that right now. Okay. If you look over here, there are so many number of rows that manually involved be visible for me to actually check out if there are any missing values. So I could do one thing. What I could do is I could go and add certain rules. What are the rules? Replace unimportable cells with NaN values. So if there's a missing data, I can add a rule over here. If you want to add more rules, click on this plus sign. And over here, what you can do is you can add a new rule. So what are the rules? The rules are replace those rows, exclude the rows or exclude the columns. What if I do this, explode rows with unimportable cells? And there is also a color identification for this particular rows. Click on OK. And what you find out over here that one more rule is added. So what you can do is you can click on plus sign to add this rule, add those rules. And if you want to edit the rule, select a particular rule that you want to edit. Go to this edit option, edit rule option. And from here you can edit the rule. Okay. So let me cancel this. And now what we can do is, we can since this is okay. This is one way you can do it. So now most of you might be thinking how to import this data. Okay. So let me do one thing. Let me click on CLC. I could go to home as I told you, and I always have an option when I can go to layout and I can select it to 2 column or 3 column. Let me select this to 3 column. Okay. So what are we supposed to do right now? So what we could do is we can go to apps. Under section machine learning and deep learning, you'll find out there are a certain number of apps over here. Classification learner app, regression learner app, and reinforcement and so on. Now the basic question is, if you look at the data set, this is my data set. And if you look at the output variable, which is MPG, what is my task? What is my task? So my task is to predict MPG, which is a number. So what I am supposed to do, I am supposed to use a regression learner app over here, right? So I'll go to MATLAB. Okay, so I'll go to MATLAB. Let me close this. Let me type CLC and clear. So, I'm now quite sure that all the things are good. I can go to apps tab. You may select regression learner app over here. What is the reason? The reason is I want to predict a number. Click on this. So what we are right now expecting, we are expecting that there should be a model, there should be app, and we are expecting this particular app to be launched. Got it? So, okay, I think I'm facing some challenge. Let me restart it. Give me a second, dear students. Let me check. Let me check out what is the basic issue over here. Okay, I think I have some issue with respect to the offline, the online version. My internet is not so good at present. So anyways, let me try to use the offline mode. Really sorry for that. Okay, so basically I was talking about regression, and I have over here this vehicle data entity. So this is the actual data set, as you can see over here. Let me go to apps. Let me go to the section machine learning and deep learning. And let me try and click on regression learner. So what we are expecting this regression learner app to be launched. So right now you can see that my MATLAB is being prepared to launch that particular app. And therefore I am not able to access few things over here. But by the time, let us check for this. So I think now it's quite clear that from column A to J, so, so from column A to J, these are predictors. So these are predictors, and column K, MPG is my response. So the regression learner app has been launched. I'll click on new session, and now you have an option wherein how you want to import this particular data set into regression learner app. So the option is either if you have either it could be from file, Excel sheet or spreadsheet. And if you have already loaded this into MATLAB environment, we can go and use it from there. We'll click on from file. And I could see a vehicle data is present over here. Click on open. So you'll find out that import data utility has been launched. It is opening up. I think I have already shown you this particular part. So what I am supposed to do is you can check a role. I have checked that it doesn't contain any missing data. So I can just click on import selection. So data has been imported. Okay, now let's have a focus on what we are actually looking at. So what you're looking at is a data set which consists of 233 by 11. So 2337 indicates the number of observations or rows, 11 are the columns. So now you need to select the predictor and the response. How you're going to select it? For the response, you can click on whatever you want. So if you look at the particular data set, you can select weight, you can select CO2, you can select AV speed ratio because these are all columns which are numeric in nature, right? And all the category columns are not listed over here. So you can select MPG because I'm interested in that. Let's go to next category, which is predictors. Here you'll find out all the columns are listed and checked. And the one which you have selected in the response one, that is unchecked. That is MPG. What if we change MPG under response to CO2 emission? We find out under predictors, CO2 is unchecked. And now we can predict CO2 from this particular data. Let's click on MPG. On the right hand side, you may find out certain validation schemes are there, which will help you against overfitting and against some particular problems that may arise with respect to the data set. Okay, what are this? So there are three schemes. One is cross validation that can protect you against overfitting. In that case, you need to decide what would be the number of cross folds, 5, 10, 15, whatever you want. So by default is 5. You can change and you can set it to 10. Next schemes are holdout validation. So when the data set is large, we can use this to understand, okay, that we are actually splitting what you can say for validation and training data. The third one is resubstitution validation, which provides you no protection against overfitting. And the same data can be used for both training and validation. We'll go for the first one, 10 crossfold validation. What is the next? I want to keep aside. I want to keep aside test data. So I want to split up the data. So how am I going to actually split it up? I am going to split it up as 10. So 90% will be used here for the training and the 10% here will be used for what? Testing. Okay, let's click on the start session. Let me explain you this because this is really important for us to understand what exactly is happening. Okay, let me close this. Now, if you look over here, I have certain tabs or panes. I have a utility for feature selection, principal component analysis, optimizer under options. Just a second. So, okay. So now you see, I was talking about feature selection. I will come to this point. Okay. Then you have models over here. There are different models. If you can see, I will be talking about these models. Don't worry. And a random forest will be talking about the back trees and symbol models and all that. Then we have training, which algorithm we want to train. We have plot for responses to export the results and export them. Let's click on first the feature selection. To explain you this feature selection, let me go to my data set first. This data set has only 10 predictors. Let's talk about a data set which have 100 predictors. So you will have 101 columns, or the last column is your response. And in that case, you might not be thinking of using all the columns. So how to decide which are the best predictors or best parameters relevant to the response MPG? How to do this? Or are certain techniques are present to do this? Yes. So MATLAB support this, and how it supports this, we need to go to this feature selection. With relevant to your data, MATLAB automatically talks about certain feature ranking algorithms. So this is MR algorithm. There are a lot of algorithms if you see. Okay, let me talk about this. Okay, so there's an help window over here, or you can press F1. Let me talk about feature ranking. I don't know if you have studied this as a part of your academics, but these are really relevant if you want to basically, understand what are the feature learning kind of things. So what I can do is, if you see over here, feature ranking, feature ranking, feature ranking, right? Feature ranking algorithm. So let me click on this. That tells you feature selection and all those sort of things, right? Can you see there are different kind of feature ranking algorithms that are being available for classification learning? So they are MRMR. What does MRMR stands for? Minimum redundancy, maximum relevance. So basically, it will try to find out the features or the columns which are more relevant. Then you have chi-square test, you have relief, ANOVA test, social wellness test, and so on. So there are a lot of features actually, feature ranking algorithm that are available. I'll be doing this kind of thing. We'll be talking about this. Okay. Okay. So if I click on MRMR, wonderful. I've been able to get the scores for all the features. Now someone tells you, you need to decide which are the most relevant one and which are the one that are non-relevant. How you decide it? So you can decide that I need to first select, I need to have only 5 such features. So you can put 5 over here. I'll put 10 at present. Or you have an option where you can decide how you want to select the features. So select individual features. Click on this. So comp is not giving me a valid score. So I'll uncheck this. I'll uncheck this. So if I keep a threshold to be 0.8, then I can find out that the first 5 features are the one which are the best. I want to select all the 10 features. So click on this. Next, you have over here PCA. Can you see what is PCA? PCA stands for Principal Component Analysis. If you want to enable that, you need to click on PCA. Over here, you can decide the explained variance, which is 95%. And for this, the number of components that will be selected are 7. This is one way you could do it. Another way is to specify the number of components. And then you can go ahead. Now you have two options over here. Options are under models, you have a list of different models that can be used for the purpose of regression. So if I select all of them will be queued up over here for the purpose of training. So let me show you what if I want to train all regression models. So you have linear regression, stepwise regression and all that. So if I want to go with linear one, I can click on linear. So under models pane, you'll find out entry number 2 indicated by linear regression. And then it asks you how you want to tune the model hyperparameters. You want to use linear, pure quadratic, and so on. I'll keep it to be linear. You can select the robust operation to be on and off. He tells you what are the features that you have selected. PC is disable, optimizer is not applicable. Okay. Now click on train selected, and then you will find out that the training has begun. And very quickly, you will find out what is the model performance. Now, to find out how you are going to evaluate this model, let's try to check the summary of this particular model. So in the summary, you can see it gives you training results. Can you see this training results? I'm clicking on documentation just to explain you what they are. Now, you might be using Python or you might be using MATLAB, doesn't matter. But what MATLAB does is MATLAB gives you a summary of each model. And now you might be thinking of which particular parameter I should consider to compare different models. So you can find out here there is RMSE validation. Okay, but if you look at the summary, they have explained you what does this statistics talks about RMSE, R square. Okay, this is MSE mean square error, mean absolute error, prediction speed. Now prediction speed is something that is a time taken by the model to predict on some new data, right? Then you have training time and model size. Why this model size is important, because after training you and validation, when the model is giving good performance, you might think of, flashing it into a ECU or a microcontroller, specific microcontroller of your choice, right? So I'll come to the remaining part of the documentation. First, let me show you this thing. So I think the statistics part is clear now, the model metrics. Returning back to MATLAB. So this model has a minimum or the best RMSE value of 3.2555. R square is 0.86. MSE validation is so and so on. Now you might be thinking, okay, I want to evaluate all the models. What I should do? Click on all. So you have a new entry, which is 3. It is entered by the name multiple, and all the models are selected. Just click on train all. And now what you see is what you see is right now that the training has begun. Now, what I'm interested in, so if you see the model which has the best RMSE validation or the minimum root mean square error value is shown by a bold font over here. So it is model 3.2 currently. And few of the models are queued and few of the models, you'll find out they are still training in the training. So you have options now how you want to view the model. So the options are, do you want to, have a list of models with the RMSE validation? If I do this, best one, but the best model right now so far is 3.2. The second model is ensemble, which is back trees. Then I have a tree and so on. I think that is sufficient enough for me. And even though there are certain models which are being training right now, I'm not interested into that because I need to decide the threshold. That 1.9 or 1.7 would be the one which is are the best for me. Now, let's click on model 3.2 because we find out that it is the one which is giving us the best uh, RMSE value right now. Click on this. You can look at the summary. The R-square value is close to 0.96, which is really good for me. Let's look at the model hyperparameters because this is the one which basically all of you should be interested in. What's the next step? The next step is to understand the model behavior, okay, with respect to some data visualization, some visualization. So let's click on response first. If I click on response, I can actually look over here that on the y-axis, I have response MPG. And on the x-axis, I may be able to record, I may be able to see certain record numbers. And now I want to find out that what will be the response of MPG with respect to CO2. Let's click on this. And now this is the response. So what basically it's talking about? If you look at this chart, there are two colors over here. So this is the actual CO2, actual data. Now this one is the actual data, which is there in my Excel sheet. So this is the data CO2 in MPG. I want to understand that if I use the model 3.2 linear regression 1, how it would be predicted. So click on this. I think it's performing really well. Let's take some other parameter. For example, you may have over here rated HP. So this one is true. And I have over here predicted. Most of the time, some of you might be also interested, in error plot. So check on this error and you may try to find out that this is the error plot. If you want to save this figure, you can click on this option. It gives you three options. You can save this figure, save as, copy the image, and copy as vector. So if I click on copy an image, okay, I go to Word document. Let us suppose Microsoft Word over here. Click on this. And if I do Control V, you can see how easy it is to copy all those results. So what basically I did was, let's have this Go to this option. You can click on the option copy the image. To copy the image, go to your Word document, Control V, and you can copy the image. Fine. Okay. Now I want to go for the response plot. Let's click on predicted versus actual. This is pretty good for us. Actually, you can see that there is a solid line which is being passing through all the data points over here. I hope you understand how to evaluate this. If you look at the spreading, if you look at this, the line which starts from 0, which is able to split the data equally, somewhat equally, we could say. Okay, is the one. Now, what is next? So you have all other plots. Okay, let me try to compare this model with the model which is giving me the worst result. So if I look at the model which is giving me the worst result or the bad result is model SVM. So if I click on SVM, this is 3.15. And if here I go for predicted versus actual, can you find out that this is a very, very bad result? It doesn't make any sense. You can go to layout and you can put it into compare model mode. Now here I can actually observe the two models and I could find out that model 3.12 is much more better compared to model 3.15. Okay. Okay. Now, while I was explaining you the results and the metrics, I found out that I've got a new result wherein it is telling me that the neural network is the one which has given you the result 1.488. Let me select this. So I will just close this one. Okay. Go to layout. So we have model 3.2 and model 3.23. So for model 3.2, this is the response plot. Let's go to model 3.23 and let's try to check out the predicted versus actual plot. Let's try to put them into compare models. Okay, so a quick response from you, dear participants. What do you think? Which one is better fitted to the data? A quick one in the chat from you all. I think I've kept the chat open so that every one of you can. Okay, so where can we define the scale of the graph? Okay, I'll come to this point. Okay. Can anyone explain which is better? Which is better? What you can say model right now? What my observation says that model 3.2 is best so far. Okay, fine. Now, most of you might be thinking of like there are so many models which are still training right now, and we are not interested into wait for this time to train. So what we could do is we can click on manually to stop the training. The training will get cancelled. And now if I try to put this as MSc validation or MAE validation, accordingly we'll find out the data will get arranged. What if I want to export the results? So to export the results, you can click on result table. Good. Can you observe? It gives you a list of different models that have been trained, and it also gives you the metrics for validation. But I am able to see that certain columns are missing values. MAE test, MSc test, RMSc test, and R-square test. What may the reason? The reason is we have not actually tested these models, but we have created the data into train and test when we started this particular session in a regression learner app. So now what we need to do is we need to go for test tab. And in the test tab, you have an option. Now the options are you can select only the models which you are interested in, or you can click on test all. And if you click on test all, you know what it will do is, so in the learn model, whatever values you have got, these values are with respect to training. If I go to test, so during training, what do you find out? You find out that 3.23 is giving a value of 1.72. Okay. If I go to test, again we find out that model 3.32 is the one which is giving you best results so far. So now you want to, okay. So for test, if you want to check out, you can click on this, you can click on predicted versus actual. So this is for the test data, okay? You can see the option test predicted versus actual and so on. Okay, fine. Click on result table. And you would be able to see that if I look at this particular model, model 3.23, I'll select one from neural network. Second one, I will choose GPR. And let me test 3.2 and 3.70. So these are the models, that I want to export. The results I want to export. So what are the options? So if you look at the options are select columns to display. Okay. Next option is export the result to workspace. Export the result table to a file. Let me click on export the result table to a file. Remember, I have chosen 4 models. If I click on this, the result table will be saved over here. Save. I'll go to my folder. If I go to regression, can you see a result table is there? Let's open this. Are you able to see now what has happened actually? I have been able to get the data for all the models. And you can see the models which I checked are 1, have entered with 1 over here, another favorite column, 1, 1, 1. Rest all are zeros. Are you able to see this now? Okay. Let me show you how this thing would be helpful if I take this to workspace. So now click on workspace. So the name is result table 1. Okay. Let's go to MATLAB. So this is my result table 1. Let's open this. And now what you need to do is you need to plot these results. So how to plot these results basically? So I should be into plot tab. Let's click on column. So press the control key. I'll click on this model, RMSE validation. But if you see, only the favorite is selected, right? So click on this, click on this, click on this, click on this validation. Click on the model type. And now what I can do is, I can go and I can select a particular plot if I want. I can plot it. But just to show you, let me select only the one, which is RMSE validation. And what if I select a bar plot over here? What it gave me? It gave me the RMSE values for all the models. Another way is, let me have this two selected. Let me go for a box plot. Can you see over here what I've got? So if I go to my app, okay, I have this different models, right? So this is a box plot. I hope you know how to identify the box plot. The red color line indicate medians. Now here I am overall trying to understand which are the one which are giving me the best results. So you could directly see that neural networks are the one which are between 0 and 2. Then you have GPRs. There is only one model, so I could say this. Then you have linear regressions. So it is indicating the median value and so on. Okay, let me close this. So just to tell you how we can go and use this result. The last one which I wanted to show you, and after that probably we can have a break of 5 minutes. Explainability. Let me close this. So what do you understand by explainability? Now see, uh, most of you might be thinking that how this particular model has taken the decision, whether the decision was right or wrong. So this is like human-like approach. What if this approach could be applied to ML models or DL models? So the two techniques that could be applied to ML models are local Shapley and local line. Okay, and if you go to local Shapley, you can read out what it says. If a train model is given, if a train model is given, we can use this Shapley based explanation and can find out some sample query points. And this query points will help us in understanding the deviations of the predicted one and the average one due to the prediction. So same is the case for line. I'm going to local Shapley. So click on local Shapley. Now the model which I am interested over here is model 3.23. Okay. Now, do you have any challenges, any question you want to ask? Dear participants, any questions you have? Okay. So this is all about interpretability. So the first thing is how you want to select a query point. Do you want to select it from the plot or you want to select as a table? Also, so the first thing is I need MPG versus CO2. So I've taken this. I think we had already seen this kind of plot. Now I want to go with table. So when I go with table, what are you able to see? Are you able to see MPG? So the actual value is for the first data point or the first row, the actual value is 38.500. But the predicted one is 37.2494. And the rest of the columns are as it is. Okay. So this is with respect to table. So what we can do is, now there are 233 entries if you remember, right? So you can say 233 entries. So you can select any random query point. So let me select one from the table. Before that, I have clicked on this row 1 and you can find out that this is indicating that CO2 has a prediction value of Shapley value of 10.13 for this query point. Excel ratio is some value, Shapley value. Weight has some value. And the 3 CO2, LX weight are the one which are major contributor. Let's forget about whether they are positive or negative values right now. Let's go to a random query point. So any suggestion which query point we should go for? So let's suppose I go for 82. Let's wait. What it's trying to do is it is trying to compute the Shapley values for index 82. And once it has been done, again we have two options. Do you want to have a plot of it or you want the Shapley explanation in the form of table? Okay. So if you look at point number 82, MPG value is 23.100. The model has predicted this value to be 21.9514, which is very close. Okay. And CO2 value is 384. Okay, fine. Again, if I look at the model, I find out that the two predictors that it has chosen is CO2, weight, engine display has occurred over here. It's fine. One addition of one more and EV speed. Now, if I click on table, we can find out with respect to the query point number 82. It has given me the shapely value. Now I have a shapely value for each and every predictor. Now someone can say that looking at the table, it doesn't make any sense. The highway value is 0.89, truck is 0.45, transmission is 0.05. That's fine. This is just for the purpose of understanding. We can uh, exclude this column later on if you want. Okay. Okay. And you have training data. You can select this for the training data. You can select this for the test data. You can do a lot of things you want to do. Okay. From here, you can select the number of predictors that you are interested in. So someone can say, is it really necessary to select a predictor point, query point from this table? No, not required. You can select it from here itself. Okay. Okay. Let's talk about line. And then if you could see, there are certain options. Okay. Export the results and all that. I'll come to this one. So this is all about line. So the same analysis predicted versus actual. Okay. The scatter plot is there. Okay. And then on the scatter plot, you can select what you want. Right. Okay. I'm not going for the scatter plot. I'm going for the response. And here I want CO2. Same results. Go to table if you're interested in. If I select the first query point, you can see now the line method has predicted the first one, two, three, the five one. The best predictors so far are transmission, city highway, com, axle ratio, car truck, and so on. Okay, let us go to the query point number 82 as discussed over there. Okay, so this other things. Right? I can click on table value, and now these are the results. Now the most important thing over here is to understand the results. So if I could show you this, look over here that the model value predicted is 2.92. Can you see? MPG value prediction is 2.9, 21.92. And the line predicts this value to be 20.86, which are very close. Okay. What if I go to Shapley? Okay. For the same 82, let's try to find out what this explanation have to tell us about. Okay. So if you see over here, if I go to annotated block, so basically what we find out that the model prediction was 26.152 and the query point prediction is 15.70 over here. So this basically help us in understanding how the model is using the predictors in the data set to perform this kind of things. Okay. The last thing that I wanted to show you is how to export the model and how to export the results. So there is a button over here which talks about export the result table. So the entire table could be exported. Okay, in the workspace. If you go to test, you can export the result. You go to learn and click on export the model. Now you could see there are two options over here. One is the export model so that you can make a prediction on new data. I'll show you this, how you can do this. And then export a model for deployment. So I'll click on export a model, but then it depends which model you are interested in. So I'll click on model 3.23. Then I'll click on export the model. You can write a name to the model, whatever you want, my model or something like that. Let's click OK. So this model has been exported. So now it's telling you how to get the new values with respect to the table. So let me do one thing. So if you look at this Excel sheet, vehicle data, the first 10 are the predictors and the last is column. This is what I want. So I'll define like this: new data is equal to okay, the first thing is I need to import that vehicle data. Okay. So I'll go to home. I'll go to click on import data. Let's take this data. Click on import selection. Then we can go for new data is equal to, we can write down vehicle data. In, in vehicle data, we can go with all the rows. We can go with the column 1 is to END -1. So basically what we are trying to do is, if you know the slicing operation, we are trying to, okay, let me do this. I'll do this for column 1, row 1 only. So if you see over here, by using this command, I have extracted the first row where MPG is not there, right? Okay, now what I need to do is, I need to use this function, yfit. You can go to yfit, and here you can replace this t value by new data. Enter. So the value which I've got is 40.8776. Let's go to our Excel sheet and find out what's the value. Okay, so if you look at the first column, the value in the data set is 41.3. And the value that my model has predicted is, and the model has predicted is 40.8776. So are we close enough in predicting this particular value? Hello, participants? If you could give me some kind of response.
Yes, students.
Okay, so ma'am, we can do one thing. We can take a break of 5 minutes, and now in later 20-25 minutes part, I can show them some classification kind of thing, where I will try to take some ensemble models over there. So shall we take a break, ma'am?
Sir, we
Hello?
can take a break of 5 minutes and then we can continue.
Yeah, yeah. So dear students, we are taking a break of 5 minutes. If you have any questions regarding anything that comes up to your mind, just you can put that in the chat box. We'll get back to you in 5 minutes. Hello. So let me, okay, let's say if there is something in chat box. Okay, thank you, Nikhil, for your reply. So to answer this question, Samarth, what MATLAB will do is it will automatically scale all the graphs for you. If you want to manually do it, then then you want to take it to the MATLAB environment, export it and plot it under. Okay. Okay. Let me go to the next one, which is this iris dataset for classification model. Okay. And probably after this, we could conclude for today's session. So, okay. So, if you talk about iris dataset, so from where we would be able to download this iris dataset. So, one thing is you can go to this UCI machine learning repository, wherein you may find out that you are able to download the dataset. So, in MATLAB, we'll find out most of the datasets are from this particular repository, where a proper reference has been given to them. So you can see iris is the one. I click on iris. It talks about the dataset information. So, there are 3 classes. Each class has 50 observation. One class is linearly separable from the other 2. And the our task is we need to classify the class of iris plot. Right. So if you look at the variable table, the table consists of 5, what you can say, 4 variables and one is class response. So here we find out sepal length, sepal width, feature length, petal width. These are the roles. The units are in centimeters. Okay, and few other sort of things are present in it. Now, MATLAB has also got the shift examples. All those codes have been already shared with you. And now what I'm doing is I'm trying to use a MATLAB live script over here. Okay, so either you can use this machine learning repository to download the dataset, or this dataset also comes to have shift dataset in the MATLAB. So let me quickly do this for you. So the first command would be to clear the command window and the workspace environment, load the dataset. So if you do this, let me type a keyword who over here. Now, if we load this dataset, we find out that there are 2 variables. One is MEAs and species. What do you mean by MEAs and species? So MEAs basically, if I talk about MEAs, so what I see over here that there are 150 observations and 4 columns. This is sepal length, sepal width, petal length, petal width. Size is 150 by 4. And if I click on over here species, you can find out this is Setosa. The first 50 observations are Setosa. The next vesicular, virginica, and so on. Now, once we have this information with us, we are interested in going and plotting this. So how we do this? For this, we use a scatter plot. So this is sepal 1, sepal length. This is sepal width. The colors that are being used over here are RGB. So R is for the classes, Setosa, vesicular, and virginica. So red color are represented into circles. So we have over here. green will be represented as square, and B would be represented diamond for Setosa, vesicle, and virginica respectively. Let's try and click on this particular line 6, 7, 8, and you can see a plot over here. Let's try to understand what this plot basically talks about. So basically, there are three classes, right? What are the three classes? Setosa represented into, Setosa is the one which is represented into red one, right? So if I am supposed to draw a cluster of this, you could see that these red color circles are very easy to identify. So I could say that this is my cluster one. Now, when I try to do the same thing for vesicle and virginica, you can find out it is not feasible for me to separate the green color one and the, what you can say. So let me choose green color one. So if you see, this is the one where I find out the green color squares are present. But I could see that within this boundary are contained some diamond shapes. Okay, so if I go for this, I could see that, this is somewhat like this. And this indicates that Setosa is very easy to separate, while the other two classes are, it's not possible to actually separate them. Okay, so that is a challenge for us. Now to further understand how we can do it, so what we can do is in MATLAB, we have a function known as box plot. And with the help of box plot, we can go for comparison of sepal length and petal length. So the median value for sepal length is shown in this orange color over here. So this was sepal length. Okay, and this is the median value for petal length. So we can very clearly identify that the sepal lengths are between 5 mm to some 6.5 mm, and the petal lengths are between what you can say 1.5 up to basically we could say around 5.8 or something like that. Okay, so I want to check the sepal length of all the species. So if I do this, I could very well understood that. Now, when MATLAB gives you this plot, you can very well understood that for Setosa, these are the boundaries. But if I go to vesicular, these are the boundaries. And if I go to Virginica, say these are the boundaries. So I understand that there is some problem, right? Some problem over here. I could say there is some issue over here in this particular area. And that's the reason vesicular and virginica could not be separated by using the variable sepal length and sepal width. Now you can go on repeating this kind of analysis for you. Basically, this is known as exploratory data analysis. Okay, so the above one was for sepal length. Now this is for petal length. And you can now understood that, okay, I can use petal length actually. So petal length could be one of the parameter because I could clearly see the boundary. So if I see this boundary, there is clearly a difference with respect to petal length. If you look at this boundary, there is clearly a difference at the petal length. So what we could do is we could use petal length over here for the purpose of classification. But now see, what would be the problem? The problem is, if you look at this data set, you have 4 variables. And if I reject 2 variables and choose only 2 variables, it means I am losing 50% of the data set over here. So this is not a good option for us. Right? This is not a good option for us. Therefore, we need to develop a machine learning algorithm wherein we try to choose all the predictors. So what does line number 34, 35, 36, 37, and 38 indicate? That since we have two variables over here, which are MEAs and species, I want to form a table known as Fisher table. I use a keyword over here, table, which is a function available in MATLAB. And the parameters that I'm interested in are, the first one is sepal length, sepal width, petal width, followed by the species. Now, how I'm able to aware, uh, how I'm aware about this particular thing is because if you go to this species and if you look at this table and you look at the variables, so the variables are, if you could see, sepal length, sepal width, petal width, and class. Where class is the one which is categorical. Okay. So in the first one, what we have done is we have used regression model. I'll go to apps. We'll click on classification learner because my task is now to classify the flowers into Setosa, Virginica, and versicolor. Okay. And you'll find out that the workflow is almost similar to the regression learner app that we have chosen over here. So this is the startup page for classification learner. Now click on new session. Click on from workspace. So under workspace at present, you cannot see the table over here, right? The reason is I need to run this. Now I could go to classification learner, click over here from the workspace. The Fisher table will be appearing for me. So where is Fisher table? It is over here. Select it. Can you observe over here that this Fisher table basically consists of only one categorical variable, which has three unique values, and therefore there could be only one response over here. So we have four predictors and one response. We'll choose the validation scheme to be 5. Validation scheme to be cross validation. We'll keep this to be 10. If you require, I could keep this to be 10. Set aside some data. So I have set aside 10% of the data. Click on start session. And now we are going to focus on some data visualization. So I had shown you data visualization using some command line interfaces, command line instructions over there. If you look in this particular app, I could select the X and Y variables as predictors. What if I take petal length and petal width? Yeah, I could see that they are very well separated. I could see 3 clusters over here indicated by blue, red, and orange color. If you want, you can just check out this. Right? Okay. Select the model. So either I could select all decision trees. So I will select decision trees over here. And I will select ensemble classifiers also here. So let me select all decision trees. So I will take all trees. This is one. So let's train it with decision trees first. So we can find out that the training process has started. You can see the status, it's training. We can look at the accuracy, which is so max accuracy, which I've obtained right now is 97% over here. So almost all are same, so it doesn't matter which one we choose. So if I choose model 2.1, I could see the summary. This is the summary. This is confusion matrix. So what do we mean by these blue boxes? The blue boxes represent the two values. It means there were 45 classes of Setosa, 45 Setosa classes, 45 observations. 45 of 45 are correctly classified. If I come to vesicular, 42 are correctly classified as vesicular. This is predicted class, but 3 are misclassified as Virginica. If I come to Virginica class, out of 45, 44 are correctly classified and one is misclassified. Now you might be interested into TPAR, FNR, true positive rates and false negative rates. Click on this. So the blue color one which you see are TPRs and these ones are FNRs. Okay, now let's talk about ensembles. So I'll choose all ensemble. So here boosted trees, back trees. So back trees we can say almost you can relate it to random forest over here. Okay. RUS. So let me select all ensembles. Let me train them. And now we need to find out which are the one which will help me to get better accuracy than this, or it will give me less accuracy. So nothing to worry. Like you might have seen that this model 3.1 doesn't give me an accuracy of uh, very good accuracy, and the highest accuracy which I have attained is 95%. Right. So this is the accuracy for ensembles. If I want to improve this accuracy and I want to use ensemble only, can I go to an option known as optimizable ensemble? Let's click on this. You can see over here, it have different parameters now, the hyperparameters, decision trees and all those sort of things, the number of learners and sort of things. So let's click on this and I want to understand that when I go and optimize the hyperparameters, now you can choose on which hyperparameter you want to optimize. Okay. You can select them from here. You can also select the ensemble methods, ADA boost type, RU boost or back or something like that. Now, when I click on this, what it will do is it will automatically try to find out of this three, which one is the best. Okay. So let's click on this. Train. And now we'll find out that we are getting a plot over here. Look at this particular box. So I am highlighting this box for you. So basically you understand what is happening over here. So look at this box. It will keep on changing certain values for you. Can you see? The values are being changed now. Ensemble methods, number of learners, learning rate, maximum number of splits, and sort of things for us. So what basically it's trying to do is it's trying to find out that which particular combination will be the best for getting the highest accuracy. Now, it may take certain amount of time for us. So let's wait. Let's wait for certain time. So okay. And by the time, if you are interested in understanding what is minimum classification error plot and how does it look like, so let me take you to the MATLAB documentation. So we are expecting a plot like this. In this plot, what do we expect? We expect there are four parameters that we are supposed to observe. The blue circles, light blue circles, indicates estimated minimum classification error. The solid blue circles indicates observed minimum classification error. The square indicates best point hyperparameters. And the yellow one indicates minimum error hyperparameters. And then the final result will be shown like this, optimization result. So these are the results which are going to give you the best values. And if you see MATLAB documentation actually consists all this theory behind it, the explanation that is being required. and the optimization results are also explained over here. Okay, so this is the documentation. So from the app itself, what you could do is you could directly erect all of this. Now, someone may be thinking of like if this kind of optimization is available for ensemble, what could be different algorithms for which it may be present in MATLAB. So if you are thinking this, your approach is absolutely correct. And if you look at the MATLAB documentation, you will find out you have optimizable tree, which tells you what hyperparameters you can choose. It has discriminant analysis method, so optimizable discriminant, optimizable naive Bayes, optimizable SVM, optimizable efficient learn, ANN, kernel, ensemble, neural network, and so on. Now, this may be different if you go for regression or some other kind of thing. Okay, so I could say that let me close, let me because it may take certain amount of time, so I'll just try and I'll just cancel it. But yes, what I could do is can I try an optimizable tree because I hope it will train fast. Okay, so I'm expecting the optimizable tree to be trained fast. It's cute right now because the NSML1 is already we find out it's training. But yes, as I told you in MATLAB documentation, if you are thinking which particular, what you've chosen is we've chosen tree, right? So now it tells you that how the splits have been calculated. So 1 max, 2 comma n minus 1, where n is the number of observation. In our case, it's 150. So I think you can directly get the values from here. Okay. So what are the additional parameters we are looking for? Surrogate decision and maximum surrogate per node. Click on this and you can find out all different hyperparameters are there. So now you can decide, okay, you will use surrogate distance splits only when data is missing. Okay. So all these things are already available in the MATLAB documentation. I will suggest you can go for the MATLAB documentation and you can do it. So anyways, I think it's MATLAB is busy right now evaluating the ensemble model. Okay, so we'll move to the next part. Okay. So just to conclude this, most of you might be thinking of that if I want to do certain courses that are available in MATLAB. So what I should basically go for. So you can, so this is your MATLAB portal. If I scroll down, you can click on view self-placed courses under the section get MATLAB and Simulink. So click on this. This would take you to the MATLAB Academy page. Under MATLAB Academy page, go to home. So if you are under home, you will find out that there are a lot of self-placed courses available over here. Now you can decide upon what is the path that you have chosen. So if you have chosen AI, machine learning, and deep learning, click on that. It gives you different courses that are being available over here. What if you go with machine learning online, which is a foundation course? Click on this, and it tells you you require certain prerequisite. What's the prerequisite? Prerequisite is MATLAB on RAM. Anyways, assuming you know MATLAB on RAM, I can click on overview of machine learning. I can start the module. So this is something, wherein you can do a self-placed course at your own pace. Basically, it starts with certain modules. You can click on this video. And this video basically gives you an overview of what machine learning is and so on. Click on next. It shows you the classification workflow. Click on next. And now it is setting up an environment for us when we can do a hands-on sessions. So this is an example of handwritten data, wherein you have got two parameters x and y. And based upon the values x and y, you need to classify whether the particular letter that you have written is J, M, and V. Okay. So you can see now it gives you an instructions, right? So it tells you that you have a data. So this is my task. And what it basically tells you, you need to read the data stored in the j.txt file into a variable later. Now to do this task, the instructions with commands are already being shown to you. So go to task 1, write the variable num later. Simply write read table, and you may enter your file. So what is your file name? Your file name is j.txt. Click on submit. And if this step has been correctly evaluated, you will find out an option correct. You can click on next task. And then what it tells you that you need to separate out the x and y values. So how you'll do that? So you have capital X is equal to, what's the table name? Letter, right? So I can write letter dot, and I can have X. Similarly, if I write Y, I can have letter dot Y. Submit this. So you can find out this is pretty easy for you. If you follow this type of workflow, okay, you would be able to basically, understand what exactly is happening. So if I go to task 2, okay, so something is missing. So what is missing? In task 3, I need to plot. Okay, that's the reason it's giving an error. So what I can plot? So it's asking me to plot the x variable on x-axis and y variable over here. Don't worry. Okay, if these are not correct, you can interchange the x and y positions over here. So this doesn't seem to be J right now. So someone asked me the question about scaling, right? So this is not a proper representation, as you can see. So now let's do one thing. It's asking me correct the aspect ratio of the plot by using the axis equal. So you can go to hint, and hint will basically tells you that if you write like this, axis equal, if I try to submit this, so what basically I'm interested in this figure. Now, if you look at this plots, the two different plots. So if you look at this plot, this gives you a proper representation, which is like this, J and a dot over here. So what basically we have done is, if to tell you, look at the axis. So the x-axis is 0.2 to 0.35. When you go for actual axis, okay, what we are able to see? We are able to see that they both are equal. And hence the reason we are able to see this thing. So I think it's now time where we can conclude this particular session. So ma'am, if they have anything, any question, any challenges, they are free
Yes,
to ask.
student, if you have any query, please unmute your mic or put the query in the chat box. Hello. Hope all the students are with me. Ronak, Nathan,
Yes,
Sushant.
there's a query in the chat.
Yeah, sir, one of the query from the Nikhil in the
Yeah,
chat
we'll
box.
just check that. Yes, you can run Jupyter Notebook files over here. Probably if you want, ma'am, we can go with next session, wherein I can show you MATLAB and Python interpretability for AI applications. Wherein we will run Python functions into MATLAB environment and MATLAB functions into Python environment. It's possible. So to answer this, let me check if things are working over here. Okay. I can go to, okay, I need to cancel this first because if I go to MATLAB, okay, so probably what is happening, some application is running over here. That's the reason I'm not able to show you that. But yes, it's possible. If you want that session, I think we can have that session. Any other question?
Any other questions from student side? Yes, Rana?
I guess there's no question with that.
You're not audible.
Hello.
Okay. So no further question from student side.
Okay.
Ronak, you have any query?
So ma'am, just to tell you,
No,
like
ma'am, no.
if you can see, the Python environment is being accessible to me from here. Okay, and if I type this py.sqrt, something like that, 42 or 43 or something, I may be able to run this particular Python scripts. So probably we can plan this as the next session. So if there are no further queries, I think they can conclude this session now.
Yes, we can conclude, sir.
Ajay, if you are there in meeting and if you want to share something, it's fine. I don't know if it's there in meeting.
Yeah. Yes, Ronak, I request to conclude the session.
Yes, ma'am. Thank you, sir, for this informative session regarding the basics of machine learning and giving us the as how to use MATLAB for machine learning tasks. Hope we can have similar sessions in the future. Once again, thank you, sir, from data science as well as AI/ML branch. Also, thank you, Sujata ma'am, for arranging this session.
Thank you, Kunal, sir. Even though you are not feeling well, but you still conduct this session. And yes, we will look into the forward for the session for student as well as the faculty further.
Yeah, ma'am. Yeah. Thank you, ma'am, for
Okay.
the opportunity.
Yes, welcome, sir. Yes,
Uh,
Ronak.
sir, it would be, sir, it would be good if you could share the recording for the session today.
Yeah. I will do this. Give me a time. Okay.
I will
Because I think it
forward
will
to.
take some time. Yeah. I'll just
Thank you, sir.
click on stop recording and let's see if I can share this with you
Yeah,
also.
the students, I will send the link